All right, we're looking today at order of operations. So when we're doing order of operations, and again, this should be a whole lot of review for you, but looking at this topic, this is something that you've done since fifth grade, really. So should definitely be familiar to us. And again, we just cover this because it's something that you will use often as you go forward in your Algebra 2 journey. So looking at it, it's a set of rules that tells us what to do when, and so basically just an agreed upon, like, this is the order that we work stuff out in a way that makes sense. So if you had parentheses, exponents, and everything, anything that's inside parentheses goes first. And if you have parentheses inside of parentheses, you go to the furthest inside parentheses, and then kind of work your way down the list there. The only thing that might be a little bit of a misunderstanding, when we get to multiply and divide and add and subtract, we work those from left to right. So if I have, like down here, I've got multiplication and then division, I'd work the multiplication first, then the division. And if I've got it opposite way around, I'd work it the opposite way around. And then finally, when I've got things in a fraction, we'll solve everything we can in the denominator first, or in the numerator first, and then the denominator. Work them separately up until the end. So let's look at a couple of examples for this. So on the first one, I've got 2 to the third power plus 5 times 5 minus 12 divided by 6. And so let's remember, when I'm doing 2 to the third power, it's like saying 2 times 2 times 2. So just remembering, we're not counting by twos, we're multiplying 2 by itself each time, or doubling it each time. So that's going to be 8. And then I'm going to copy down what I've got left because I'm done with that step. Okay, so next I've got multiplication and division. And so not worrying about addition and subtraction yet, but I can do that 5 times 5 to get 25. And since it's separate over here, there's a sign in the middle of it, I can go ahead and do this 12 divided by 6 to get 2. I'll bring that sign down and bring the rest down that we have not used. Okay, our last step is doing addition and subtraction from left to right. So first thing is to add 8 to 25, which would give me 33, and we can just kind of think, well, if I get 33 here, 33 minus 2, we don't have to write that down necessarily, and we just get 31 as our answer. So when it says it should look like a V trailing down to the answer, that's kind of what it means. Just basically meaning make sure you show some work as you go along on this. Now looking at example 2, of course I've got 7 squared there to start out with, which would be 49. And then after I multiply here, notice I've got a few subtraction statements here and then addition at the end. So we're going to have to watch the order that we do that. Now multiplying 49 times 4, however you work that out, should get 196. I copy the rest down. And so when I'm working this left to right, that means I'm not adding these together, because that would give me 1 plus 11, give me 12. And then I'm just subtracting 12 from everything. So only right way to work this out is to go from left to right. So I would do 196 minus 10 to get 186. Then I would do the minus 1. And then at the very end, add 11. So that'd get me 185, and then if I add 11 to 185, it actually gets me back up to 196. So using that one just to kind of show that we need to go from left to right when we've got all that addition and subtraction. Okay, on the next one. And I'm going to skip number 3. Nothing new there other than the distribution here, where I distribute that 4 after I've done 2 squared. And the fact that I need to work out my numerator and my denominator separately. So let's look at number 4 because we're doing a lot of those same things. As I copy down my numerator over here, I can go ahead and say, well, I know what 2 squared is. And get that as part of my thing there. And I know I'm drawing the claw there kind of out of habit if we can't combine those. What's actually going to happen is we could add all this together inside, and so we're going to do that first before multiplying by that negative 4. So 4 plus 1 is going to give me a 5. And then I've got negative 4 times 5, which should give me a negative 20. And so I've got 5 minus 20 to get negative 15. And what I'll do is I'll draw a line, put negative 15 up here on the top, and then work out my denominator. And it really is a quick couple steps because I can already do 4 divided by 2, which is 2, plus 7, which gives me 9. So I end up with the fraction negative 15 over 9. So we're going to just simplify that. We're not going to turn it into a decimal number. When I simplify that, both the top and bottom divide by 3, and I get negative 5 over 3. And that's going to be my final simplified answer there. Okay, I've got, for time's sake, not going to look at 5 and 6. You've just got a few of the similar steps. Just remember when you're doing something to the third power that this is 6 times 6 times 6, not 6 times 3. So just an easy thing to kind of, as we're moving along and working, to kind of get switched up in your head. But let's remember that as we're going along. So looking at the back, this gives us a lot more negatives here as we're going along. And so I know a lot of questions come up when we have minus a negative here, especially with those parentheses. And what's going to happen with this is when I do minus a negative, it's the same thing as plus a positive. So kind of like saying it's a double negative, which changes it back to a positive. So we'll see that popping up here in a minute. But first, I'm going to work out from here 2 to the third power to get 8. So that's still in the parentheses. And my brackets there. And so because this is kind of separated like that, I'm going to kind of work this part down and then work the other part. So doing 8 minus 5 gives me 3. And so I have negative 5 minus 3. And remember, if I've got 2 negatives, I'm going to add it together and keep the sign. So negative minus a number is going to make it more negative. It's like you've lost $5 and then you lose 3 more. Like things are just getting worse. So that ends up as negative 8. Then over on this other side, I've got 2 minus a negative 9. And really what we can think of that as is if I'm doing minus a negative, it's like a debt got erased. So you kind of get that money back. So really, 2 minus negative 9 just changes to 2 plus 9. And so 2 plus 9 would be 11. And so I end up with 8 times 11, or negative 8 times 11 to get negative 88 there for that. And so this next example on 8 goes through kind of the same thing. I do want to make sure we recognize if I'm doing negative 2 to the third power like this, the way that this is written is negative 2 times 2 times 2. And so the way this is shown here, I'm doing 2 to the third power, and whatever my answer is going to be negative. Had it been written a little differently, and the result would be the same in this instance, but you have a lot of times where it will not. Had it been written negative 2 to the third power like that, I'd be doing negative 2 times negative 2 times negative 2. Now, in this instance, I would end up getting negative 8 either way, so it kind of works out in your favor when you're doing stuff to the third power, but not working this one all the way through just because I have one down here that does work out like it should, or does give you an example of one where it would be different however you looked at it. Let's move on to the simplifying though. And so when I'm simplifying, I'm going to distribute if I can. And then I'm going to combine any like terms. So combine like terms. So on number 9, I don't have any distributing to be done. So I just look and I've got a 5x and a negative 2x to get 3x. And then I have a negative 3y, a positive 3y. When I put those together, it equals 0y, which actually is just going to go away altogether. So my answer here ends up being just 3x. This next one, I've got a few more steps to do. So I notice I have a negative of whatever's inside here. So we're kind of just saying I'm taking the negative or the opposite of each of the terms here. Easy way to think about that is if I put a 1 there, so it's in that invisible 1 showing up, and I distribute that negative 1 to those different things, to those two terms. That'd give me a negative 3, and then a negative 1 times negative 6y gives me positive 6y. And that takes care of those parentheses for me, and I can go ahead and copy the rest down. So, looking at this, all that's left for me to do is find any like terms. So the only ones I see that have a variable in common are my negative 7y and positive 6y. So that means 8x gets to stay the same. Negative 7y and positive 6y leaves me with a negative 1y, which I could write just as a negative y or a negative 1y. So it doesn't have to have the 1 there. And then negative 3 is going to stay the same there as well. And that is our answer on this one. Last thing you have that you'll be doing is evaluating expressions when you're given values to plug in. So it says b is negative 3, so I'll put a negative 3 in for that, minus c, which is 4. That's going to be squared, plus 4 times d, which it says is negative 0.5. So we'll just make sure we write that correctly. As we go to work this out, I'll do inside my parentheses first, which is a negative 7. And so this is that instance where if I square something that has a negative, is a negative number, doing it in parentheses means I'm doing negative 7 times negative 7, which a negative times a negative would give me a positive, so positive 49. Had it been written differently, like negative 7 squared, negative would be on the outside and I'd get a negative 49. That has a tendency to really trip you up if you don't put it in the right way, if you're using a calculator to do something like this. Because if you put this in the calculator without the parentheses, It's actually going to give you a negative 49, which would not be correct. Okay, working through my other half, I have 4 times negative 0.5, which is actually a negative 2, because that would be half of 4. And so I just have 49 minus 2, which would be 47. So that's my answer there. Number 12 works a similar way. Notice there's no value for d getting plugged in there. So I'm just using that negative 3 and 4. And just remember, as you work this out, negative 12 over negative 3 could be written as a fraction, or you could just write it as a division statement. Either way works just fine. So you'd work this out, do this division, do the 2 sets of multiplication there, then do the addition and subtraction, and just solve it using our order of operations. All right, that about covers it for this 1.1 lesson.